The first question we face is, what is an inverse? The very trusty Wikipedia states that an inverse function is a function that reverses another function. Let's dig deeper into this concept, as this doesn't necessarily answer all of our questions. Up on the board right now, I have a few examples of inverses, and some may look related, but others, such as this last one here, looks like they might not have any connection to each other. Let's start with a few examples. My first example, y equals 2x minus 1. The first step in solving this equation would be to switch the places of the x and y. So now the equation is x equals 2y minus 1. However, in an equation you always solve for y, so we have to do that in this equation. After solving for y, we end up with y equals x plus 1 over 2. This is the inverse function to the original equation. The next step we have is to graph this equation. But before we do that, we need to write the domains and the ranges. Now, for this problem, they're relatively simple and don't necessarily impact the graph. For both of them, the domain and the range is all real numbers. However, one thing we do is we switch them. Now, normally, these might create a significant difference, but since they are the same, they are simply just still the same. And as so, we don't have any restrictions on our graph. The next step we take is determining what points to graph on this graph. We can graph the first equation here, and then in order to graph the inverse, there's a few different things that we can do. The first would be finding a point of the original graph and switching the x and y points, since that's simply what we did with the equation, and in which would give us the inverse point. We can continue doing this to find our second point on the graph, and then simply plot the line. This is the graph of the original equation and the inverse. Now, moving on to the last step, which would be checking our work to determine that everything is correct. The first equation, or the original equation, is labeled as f of x. The inverse is f to the negative first power, which of course really isn't f to the negative first power, but it's simply a descriptor for the inverse. So first we would do f of the inverse of x. What we would do here is for each spot that x is on the original equation, we fill in the inverse equation in that place. Now, we simply solve for y. In which doing so, we end up with y equals x. If you arrive with y equals x, that determines your work is correct. Let's repeat this process for the second part. First, which would be the inverse of f of x. Again, we simplify, and we are left with y equals x, which determines that our work is correct. Moving on to our second example, y equals x squared. We switch the two, and then we solve for y. We end up with y equals the square root of x. Now, once more, we have to find the domains and the ranges. For this one, at this point in time, x doesn't have a limit, so let's find the range of y. As x is squared, it can't be a negative number, and therefore y has to be greater or equal to 0. So now we have to find the domain and the ranges of the inverse. We simply switch the two again, and we end up with x is all real numbers. However, now x also has to be equal to or greater than 0. And by switching them again, now y is only restricted to all real numbers. This will come in handy when we graph our equation. We start by graphing our original equation. And now we need to graph our inverse. However, something's wrong. Our inverse isn't a function. As you can see, the same x value creates two different y values, which isn't a possibility for a function. So, in which doing so, we have to erase one part of it. But how do we make this true? Well, in which doing so, we would have to restrict the domain, or we would have to restrict the range of the inverse equation. Because we did this, we also have to restrict the domain of the original equation, since each of them are swapped. Then we can go back and erase the part of the original equation that doesn't match the domain and range. And then our equation and our graph works and is happy. Moving on to example 3. We switch the two, and this is a little more complicated. We simplify it to x equals y plus 3 squared. We take the square root, continue simplifying, and we end up with the square root of x minus 3 equals y. This is our inverse. We look for the domain and the range, and x has no limit. However, y, once more, does have a limit. Y's limit is y has to be greater or equal to 0. So, in solving and finding the domain and the range of the inverse equation, we simply switch them and we receive these answers. So, if we look at the graph of our original equation and the inverse equation, we see that the inverse equation would normally not be a function. However, Desmos very kindly simplified it for us, and then in which we just simply have to restrict the domain of the original equation, and now it works. One thing we've noticed by looking at all these equations is the lines always flip over the line y equals. This is another way. The final step we have in this equation is to check our work. So the first thing we're going to do is find f of the inverse of x, which would be this right here. You can see I've replaced the x's with the inverse of x. So then the next thing we have to do is simplify it, and which I've done down here. And our final step, the easiest of all, is just cancel out what, cancels each other out. For example, plus 9 and negative 9. Those cancel each other out, so we can cross them out. We can cross these out. Then we are left with y equals x. Simple. So now we simply have to do the other half of this checking to make sure we are correct. If you remember from earlier in the video, this equation right here, it actually transforms very nicely into x plus 3 squared. So we're just going to fill in the rest of the equation and keep that like that. Okay, I am completed with that. Now if you notice here, here's the squared, and there's the square root. You can just cross those out with each other. And then what we have left is y equals x plus 3 minus 3. We can cancel those out, and the equation ends up being y equals x. So we have concluded that the inverse to this equation is correct.